Recently, a few members of the talkSTEM board got together to go on a WalkSTEM in Koshi's neighborhood. They started brainstorming questions based on what they noticed. Some examples included the ratio of the paved surface compared to the grass, or the ratio of the glass versus the opaque material in the homes they walked by. How many different shapes were in the buildings they walked by, and why did some of the trees have dirt patches around its space while some did not? Then they decided to focus on one question based on one of these observations, and that was that even though the width of the road they were walking on was the same along its length, the two lines were parallel to each other, it looked like the width of the road was getting smaller in the distance. When would this optical illusion get so narrow that they would no longer be able to see the road at all? When would the vanishing point appear? And is there a way they could calculate this? One simple response strategy would be to measure the width of the road in the foreground and compare it to the width of the road further and away. In other words, even using these images, we can come up with a relative change in width. Artists call this linear perspective, a type of perspective in which the relative size, shape, and position of objects are determined by drawn or imagined lines converging at a point on the horizon.